All right, welcome back, BC friends. This is going over the quiz. It took me a little longer, but what I did was I worked out all the problems and tried to predict what your answers would be. Again, your order is going to be different. It's just how the test banks work. And your answer choices are going to be mixed in, so that's why I circled them nice and big in red. Hopefully we got the right ones. I also went through and did item analysis on each of these. One, to kind of see which topics we're getting and which ones we're not, but also see which topics that you're not working on yet. So make sure that you're doing that. This is an alternating series, so one of the questions that came up this morning is it going to say which test to use? Well, here it did. On number 2, as an example, determine but this should be able to quickly be identified. So yes or maybe no. So, it's part of a thinking thing. 70% of you got this right. It's -1 to the n, so that means it's an alternating power, or an alternating series. +1, -1, +1, -1. So then we have to take away that negative sign and check. Did the limit of what's left, 1 over n to the third, go to 0? Check. And is a sub n plus 1 smaller than a sub n? So in other words, is a sub n plus 1 to the 1/3 power smaller than 1 over n to the 1/3 power? Well, if you're having trouble, think about numbers, right? Isn't a bigger denominator dividing by a bigger denominator going to make that be smaller? The answer is yes. So the system or series converges. Number 2. 96% of you got this right. It was keyed in incorrectly on Canvas. P is greater than 1. Check. Converges. Nothing there. So I will go and mark that one correct for those of you that got it wrong, and incorrect for those couple of you that missed that one because you misread the problem. This one. Company makes a durable product. They think that they can sell only 75% of that quantity each year going forward. Each year, from the year before. They sold 20,000 the first year. That's a sub 1. This is a geometric series because 0.75 is your common ratio. That's what happens each time. They want the eventual sell. That's your infinite sum. So the limit as n approaches infinity. S is a sub 1 over 1 minus r. 20,000 over 1 minus 1.75. 67% of you got that right. Only 50% on this next one. Again, this is the root test. This is just the principles of the root test. Look what you have. A sub n. If that's convergent, look what you want. A sub n to the k, where k is a positive integer. If I take the k root of that, I'd get back to a sub n. Right? If this is convergent and positive, then a sub n to the k power is also going to... Did I miswrite that? Convergent. Oh, no. This is convergent. My answer key says always diverges. I think I miswrote that one. Let me check that one. I'll pause the tape right now and fix that one. Okay, I'm back. Sure enough, you can see I've crossed that off. I misread. And one reason why you have to be careful, the answers are all in different order as well as the questions. So as you go through this, look at yours, but this is not diverging. If this is convergent, then this is also going to converge. So that looked very strange. 50% that data was right. The next one I'll have to scroll up and then see what this is. So let's see if we can fit this all together. Determine if the series converges or diverges. If the series converges, find its sum. This is a telescoping series, okay? So what I did while I was going through things is this is when n equals 1, this is when n equals 2, this is when n equals 3. I could have done another term just to see, but after a while you can see that the only terms that survive are going to be this 1 over square root of 2 plus 1 over square root of 3. So that's going to converge, and the answer is that one, 1 over square root of 2 plus 1 over square root of 3. 72% of you got that one right. Yay. 89%, nth term test. This was one of the first tests that we studied. This is the divergence test in some books. Nth term test is what I would call it, so nth term test here. All you're doing is saying this. If the limit of that n over n plus 1 is equal to 1, which is not equal to 0, then it's a divergence test. It only tests for divergence. So if you said inconclusive or converges, or since the limit is 1, which is not equal to 0, that diverges. Bam, 89%, yay you. Here's another one. I need to go from page to page. Okay, that'll work. Evaluate the geometric series. Okay, well, how do I know it's a geometric series? Because I've got this. Now, I rewrote this like this so you could see what r is. But if I plug in n equals 1, 5 over 7 to the 1 power, a sub 1 is 5/7. I could rewrite that as n equals 1 to infinity, the sum of that terms 5, because it doesn't have an exponent, it just has 1 on it, 1 over 7. So I can see that r is equal to 1/7. So 5/7, a sub 1 over 1 minus r. This looks like it's 7 over 7, but it's really 5 over 1 minus, 5/7 over 1 minus 1/7. So that's 5/7 over 6/7. Flip and multiply, 5/6. Okay, 5/6. 74% of you got that one right. 59%. And as I'm going through these, yes, this is challenging topics. Okay, you got to invest a little bit of time. So don't be feeling bad. Some of you just did the discovery method, and let's see what's going to be on the test by looking at the quiz. Again, you are what you eat. Okay, you will get what you put into this. If you don't put much in, then YOLO, and I don't subscribe to that, but many of you do, and many of you will find that will be a non-sustainable, to use an overused word lately, non-sustainable activity going forward. So save the whales. 59% of you got this one right. This is a tricky one because it's asking you about convergence absolutely, or if it converges, if it just converges conditionally. I mismarked this one. This is definitely absolutely. I think I was reading through the answer key and was quickly trying to get this because I wanted to make this quiz so you could study today. So the first thing, it is an alternating series. So I'm going to look to see if this term, if the limit as n approaches infinity, of just that, the 2n to the 6th plus 1 over 7n to the 9th plus 4 equals 0. Well, bigger on the bottom, it is equal to 0. The next term is going to be bigger too, because this is a decreasing function, so that's okay. Okay, so we've checked that. I'm then going to use the direct comparison test. 1 over n to the 3rd is my convergent p-series, right? If I flip and multiply and use the ratio of those two, the one I'm comparing to the one I've got, right? So flip and multiply that, I'd get 2 to the n, 2n to the 9th plus n to the 3rd, really who cares, over 7n to the 9th plus who cares. Take the limit as n approaches infinity of those, and since we got the powers to be the same, by picking appropriate 1 over n to the 3rd power, I get 2/7. Again, it wouldn't matter if you had 7 halves or 2/7 if you flip the one you're comparing to the one that you've got. I just did that one. That's a finite and positive limit, therefore the series is going to converge absolutely. Okay, convergence, absolute or conditional convergence. If it's conditionally convergent, that just means you are relying on the -1 power to make it a -1 plus 1, -1 plus 1, -1 plus 1 to get it to converge. Okay, that's alternating series. But if you can take away that -1 sign and get the rest of the business there to of that series to converge, then series would converge absolutely. That's a good problem. Number 9, I think a lot of you were confused by this one. A whopping 7% got that right. So this was a challenging one too, okay? And it was asked in a very odd way. I like this problem because I didn't get this at first, but then I said, aha. A sub n and b sub n, we've got two series. They're both positive for n greater than some integer n. Okay, so after a certain point on from there, okay? If the limit as n approaches infinity of the a sub n over b sub n ratio is positive, that's another way of saying that a sub n has to be greater than b sub n, right? If that limit of this ratio is infinity, think about the L'Hopital's rule, if nothing else, right? A sub n is growing faster than b sub n, or a sub n's terms are getting bigger than b sub n is. Then what you can conclude? Well, what I did then is say a sub n and b sub n, and I put them in order, okay? A sub n is bigger than b sub n. And then I thought about these. Well, a sub n, a large number of you, I call this the chicken poo answer, cannot be determined. Don't pick the chicken poo answer. You know he's not really thinking poo now, don't you? Think about it. If a sub n converges, okay, so forget about these arrows here for a minute. If a sub n converges, if b sub n converges, So our conclusion, it's a little backwards. This, if this. So if this converges, this is going to stop here. B sub n is going to stop. A sub n might stop, it might not stop. We can't convince ourselves of that. Okay? So that one's wrong. A sub n diverges if B sub n diverges. Well, that's clearly the answer that's right. Okay? But you've eliminated this part here. A sub n, so this part here is false. So that's also false. If A sub n, if B sub n, and again, the if comes late, so this is a reading problem. This is a tricky question. I like this question. Again, don't feel bad if you're one of the 93%, okay? If B sub n diverges, that means B sub n is pushing out. It's not going to stop. It's not going to converge. Then A sub n is going to be pushed out. This one's rude. It's pushing this one out as well. A sub n is going to diverge if B sub n diverges. I think that one works. I thought some more about this one. My example that I gave during the conference hour was different, but the numbers were similar but different. And the reason why I'm omitting it, this is the answer they wanted. Okay, so I think this is the answer they wanted. However, I went and calculated R. R is your common ratio. One way to think about R is find a term divided by the previous term. What am I multiplying this term to get that? I'd have to multiply 3R times R over 3 to get R squared. Okay, that's nice. But then if I pick the very next one, 3r to the third divided by r squared. In other words, what am I multiplying to get r squared? To make it a 3r to the third, I'd have to multiply by 3r. Well, how could you have r to the third and 3r? That is not a common ratio. So this is not how the geometric series would work. I'm omitting this one. So I'm not even taking the, it's a bad question. Okay, so I didn't see, I just saw 3r squared, r squared. I paid attention to the r's and not close attention to the 3 there. I wonder if in the original problem that I picked from the answer bank, who knows though, but I'm going to omit that one. So this was out of 17 questions. It makes no sense. So none of these are right answers. This is bogus. All right? So don't worry about that one. I don't even know what the stats were on that one. Number 11. This one converges. I think you can see. Let me scroll it up here. Again, my order is going to be different than yours. Don't worry about that. Use the ratio test. The way the ratio test works is you're taking the limit of a sub n plus 1 over a sub n, absolute value of that, as n approaches infinity. So wherever you see an n, I'm plugging in n plus 1. Wherever you see an n, I'm plugging in plus 1. Wherever you see n, and the original 1 is going to be divided by. Well, limit as n approaches infinity. And it is absolute value. We didn't have any signs there, but I just wanted to remind you that that would be there. So flip and multiply that, and then combine like terms. N plus 1 to the ninth over n to the ninth is just going to be n plus 1 to the ninth over n to the ninth. There's no, it's not like factorials where we're going to cancel that. I could expand that out. Heavens, please don't. N to the ninth plus 9n to the eighth plus, using Pascal's triangle. OMG. Don't do that. But my n, I've got 9n over 9n to the n plus 1. Well, since it's bigger on the bottom, that's going to be 1 over 9. Think about why that's true, okay, if you're still struggling with that. So that's where I got that term there. 1/9 times all that. Take the limit of that. Well, the limit of 1/9 is 1/9. That's okay. What about the limit of this? Exponents are the same. Divide coefficients. So I've got a 1 and a 1. N to the ninth plus who cares divided by n to the ninth. Take the limit of all that is 1. So 1/9 times 1 is less than 1. It converges. This series converges. 96%. This was one that was keyed in incorrectly into Canvas. So this is P is that. This is P series. This is greater than 1. It converges. So I apologize for those of you that were a little consternated by that. I will fix that one on the ones that missed that. Sadly, for the 4% of us, I'll take those points away because it's clear that is one thing that you'd want to have. This one is also should be pretty easy because you could do the integral test because that would give us the integral of 10 over n would be 10 log n. And take the limit of as n approaches infinity, that goes to infinity. Also, isn't that n the harmonic series? So p series n equals 1. It diverges. So you could do either one. 85%? Yeah, you. Integral test again. This one's a little more interesting, so I showed some work. This one converges. if u equals 1 over x, okay, and that should be a clue because cosine, there is no du there. Oops, I need a dx here, sorry. If u is 1 over x, du is going to be negative 1 over x squared, right? So I needed a negative 1, I needed a negative 1 to finish my du. So negative 1 over 1 is 1. 1 over infinity is 0. You got one cookie divided by an infinite number of cookie? No cookie. Okay? 1 over infinity is 0. So then I've got the antiderivative cosine, negative sine u from 0 to 1. If you want to change that order, you can. Minus, minus, you could just plug in sine of 0 is 0. Sine of 1 is a finite positive number. Therefore, the integral test shows that that function converges. All right. Root test, 87% of us got this one right. That was good. Again, what you're saying is, if I take the root test, I'm comparing it to this one here, ln of that. What I actually did was L'Hopital's rule to think about this. So if you want to think about that, you get 0 for that. That's going to converge. 41% on this problem missed it. That's kind of sad because it's an alternating series where u sub n is our series, but the limit of that term as n approaches infinity of u sub n is not equal to 0. Well, that's the nth term test. Bam! It's always going to diverge. You have to check the conditions. They love these kinds of questions. So anticipate seeing more of these on the test than just the, what's the finite limit of this? And what's the ratio test of that? Okay? They seem to love these. So make sure that you understand. And nth term test is definitely fair game on this year's AP test. So I really like that question. I was disappointed that 41%. Think about the conditions. Determine convergence or divergence of this alternating series. 72% of us got this one right. Well, again, negative 1 to the nth power tells us it's an alternating series. But then I need to take the nth term test. The limit as n approaches infinity of what's left. So log of 8n over that. Well, log of that, I don't know what it is, but it's not equal to 0. So it's going to diverge, not by the alternating series. This diverges by nth term test. Okay? And the last one, ratio test. 91%, so we're ending it on a positive note. Limit of 2 to the n plus 1 over n plus 1 factorial. And then I flip and multiply and did that automatically. N factorial over 2, so you can just see that, right? Times that. So I can combine, well, I got a 2 on the top. I got n factorial over n. Oops, this is n plus 1. I miswrote that, didn't I? But still, as the limit as n approaches infinity, O of 2, right, because think about what would cancel out. N plus 1 times n minus 1, all of that. So 1, 2, 3 times, right? So work those out. Make sure that you see that everything would cancel except for the n plus 1 term. 2 over n plus 1 as n approaches infinity is definitely going to be 0. Therefore, that converges. It's finite. Alrighty? I do want to thank you all for doing the quiz. I'm a little disappointed by the grades on the quiz. I think some of us are hearing the grades can't be hurt, but your learning can be hurt. So keep working at it. I'll post this on the YouTubes for today. Don't look for it tomorrow because the test is tomorrow. I'm giving you until midnight. Do not wait until midnight. What if the system crashes? Sadness and drama. Okay? When the test is due, the test is due. So I will work on finishing up a test. Hopefully I'll try to double check some of the answers and not have to admit or regrade. But, you know, it is what it is. I don't have the ability to hand you quizzes and tests like I would in class where I have written them myself. I think this is going to work better than my math lab. Don't forget, my math lab is still due on Thursdays. I had to extend some deadlines for AB. Let me know if I need to extend some deadlines for BC folks too. But my students, every Thursday rhymes with my math lab, so I would at least check. I know my math lab has been having trouble, so do not wait to the last minute to do my math lab. Because a lot of people are on there during our online everybody's online scrambling to get things done. All right, I hope that answers your questions. This was a good quiz. Some of these problems are challenging, but look over these problems, see if you understand these. Certainly look over your notes. One last reminder, if I can find that table, which I can't seem to find. There was, in your notes, a table. Aha, I found it. And one of you asks, is that on Canvas? Yes, indeedy. This was part of your notes that are installed on Canvas. So it's been explained on a video, but these notes are available each day. It says something like day 1 notes, day 2 this, day 2 that. So this was on the day 6, I believe, the last day that we did all those. So look on Canvas and get those. But I hope you're watching videos. I know some of you are not. You've told other teachers too that you've pretty much checked out. I'm impressed. Not. You be you. You do you. But also remember that these are going to outlive the coronavirus. This is going to be forever. Whether or not you use this or not next year, who's to say? But who's to say that you're not going to use this? So do something productive with your time right now. Learn something new, because you're definitely going to be learning how to learn something new if you're not using this specific skill next year. All right, have a great one, and I will talk to you soon. Test tomorrow. No excuses, just excellence. Yeah.